Hello engineers and future engineers. Welcome back to ACP Civil Hub. Today we are going to understand one of the most important connection components used in steel structures and PEB buildings, the gusset plate connection. Although a gusset plate may look like a simple steel plate, it plays a critical role in connecting structural members and ensuring safe load transfer throughout the structure. In this video, we will learn what a gusset plate is, different types of gusset plate connections, how loads are transferred, what forces act on gusset plates, important design considerations, common failure modes, and key engineering takeaways. So let's begin. First, let's understand what a gusset plate actually is. A gusset plate is a steel plate used to connect two or more structural members together. It acts as a connection element that safely transfers forces between structural members such as braces, trusses, beams, and columns. In steel structures and PEB buildings, gusset plates are commonly used at bracing connections where multiple members meet at a single point. As shown in the figure, the brace members are connected to the gusset plate, and the gusset plate is connected to the column. The forces coming from the brace members are transferred through the gusset plate into the supporting structural member. Without a properly designed gusset plate, the connection can become the weakest point of the structure. Therefore, gusset plates are essential for strength, stability, and efficient load transfer. Gusset plate connections can generally be classified into three types. The first type is the bolted gusset plate connection. In this arrangement, bolts are used to connect the gusset plate to structural members. Bolted connections are easy to install, allow faster site assembly, and are convenient for maintenance and replacement. The second type is the welded gusset plate connection. In this case, welds are used instead of bolts. Welded connections provide higher rigidity and are commonly used where permanent connections are required. The third type is the combined gusset plate connection. This system uses both bolts and welds together. Combined connections offer higher flexibility and are commonly used in heavy steel structures where additional strength is required. The selection of the connection type depends on load requirements, fabrication methods, erection conditions, and project specifications. Now let's understand how load transfer occurs through a gusset plate. The load path starts from the brace member. When external forces act on the structure, the brace member experiences tension or compression forces. These forces are transferred into the gusset plate through bolts or welds. The gusset plate then distributes these forces safely and efficiently. After distribution, the load moves into the supporting beam or column. Finally, the load travels through the structural system and reaches the foundation. Therefore, the complete load path can be summarized as brace member, gusset plate, beam or column, and foundation. A properly detailed gusset plate helps distribute forces uniformly and prevents stress concentration at the connection. This improves structural stability and overall performance. Several types of forces can act on a gusset plate connection. The first is tension force. Tension force tends to pull the connected members apart. The second is compression force. Compression force pushes members toward each other and may cause buckling if not properly designed. The third is shear force. Shear force acts parallel to the connection and attempts to slide one member relative to another. In real-world structures, gusset plates rarely experience only one force. Most connections are subjected to combined loading conditions where tension, compression, and shear forces act simultaneously. Therefore, Gusset plates must be designed to safely resist all applicable force combinations without excessive deformation or failure. Proper design ensures safe load transfer, structural stability, and connection reliability. Now let's discuss some important design considerations. The first factor is plate thickness. The plate thickness must be sufficient to resist applied loads and prevent yielding or local failure. The second factor is bolt arrangement. Proper bolt spacing, edge distance, and bolt layout are essential for efficient force transfer. The third factor is connection geometry. The shape and size of the gusset plate significantly affect load distribution and stress flow. The fourth factor is member compatibility. The gusset plate must be compatible with the connected members and their load-carrying capacities. The fifth factor is code compliance. All designs should follow applicable design standards and codes to ensure safety and reliability. A typical design process includes load assessment, plate design, bolt design, code verification, and final approval. Good gusset plate design improves constructability, durability, and long-term structural performance. Let's now look at some common failure modes. The first failure mode is bolt shear failure. This occurs when the shear force acting on a bolt exceeds its shear capacity. The second failure mode is bolt bearing failure. This happens when excessive pressure around the bolt hole causes local deformation of the plate. The third failure mode is plate yielding. In this case, the gusset plate experiences excessive stress and begins to deform permanently. The fourth failure mode is block shear failure. This involves a combined tension and shear failure near a group of bolts. The fifth failure mode is buckling failure. Thin gusset plates subjected to compression forces may buckle and lose stability. Most gusset plate failures can be prevented through proper design calculations, adequate plate thickness, correct bolt spacing, sufficient edge distances, quality fabrication, and proper inspection practices. Understanding these failure mechanisms helps engineers design safer and more reliable steel connections. Let's summarize what we learned today. We understood what a gusset plate is and why it is important in steel structures. We studied different types of gusset plate connections, including bolted, welded, and combined connections. We learned the load transfer mechanism from brace members to gusset plates, then to beams or columns, and finally to the foundation. We discussed tension, compression, shear, and combined loading conditions acting on gusset plates. We reviewed important design considerations such as plate thickness, bolt arrangement, connection geometry, member compatibility, and code compliance. We also examined common failure modes and the methods used to prevent them. Remember, a gusset plate may appear to be a small component, but it is one of the most critical elements responsible for safe load transfer and structural stability in steel structures. Good detailing, proper design, quality fabrication, and regular inspection are the keys to creating safe and reliable steel connections. If you found this video useful, please like, share, comment, and subscribe to ACP Civil Hub. Thank you for watching. See you in the next engineering video.